Okay, Algebra 2, we are looking at polynomial graphs today. When you have to look at a graph, you're going to see how many curves you have, you're going to see where it touches the x-axis, you're going to find out where your zeros are, okay? We also learned in the past about maximums and minimums. And remember that a maximum is a high point and a minimum is a low point. So, for the first example, it wants you to determine the values of x between which each real zero of the function is located, and then draw the graph. On this one, it's not too bad, they've already done it for you, but let's just talk about what we're having to work with here. They put it into y equal and they looked at their table. To figure out where the real zeros are, is you're finding where it crosses the x-axis, which means where y is 0. So you're looking for places where it goes from positive to negative, or from negative to positive. Then you use the x values to describe where it is. It's between -2 and -1. It's between 1 and 2. Okay, they're going to be decimals. We're not going to find the exact zero. We could using the calculator, but we're not going to. We're just going to say what they're between. And then you would just look at the graph, go zoom 6 and sketch it, and there you would be. So, looking at number 1, the first thing it wants you to do is probably go over here to y equal and clear it out and put your equation in. So we have x to the third minus 2x squared plus 1. Go to your table, and we're looking for any exact zeros or any changes in signs. And I'm already seeing an exact 0, so I know that there is one at 1, because when y is 0, x is 1. So you have one at 1. Okay, then we're looking for when it goes from positive to negative. Well, we go from -2 to 1. So between -1 and 0. So between -1 and 0, we have 1. And then notice we go from a positive to 0, and so that was 1. We want to keep going, see what else we can find. We don't see any other changes, okay? So we know that at 1 there is a 0, and we know that somewhere between -1 and 0 there is 1, okay? So let's go zoom 6 and look at our graph. And I'm going to zoom in just because I like to see exactly where it's crossing. And so we have 1, 2 zeros. So somewhere between, we actually have 1, 2, 3, somewhere between -1 and 0. Okay, so somewhere over here. There's also one somewhere between 1 and 2, because there's one at 1, but then over here, somewhere between 1 and 2 as well. So I would look at this and I would say also between 1 and 2. Okay, one more look at my graph. It's going to go up, down, up, so it's going to go up, down, up. Okay. If you wanted to show some of your table work, it would be excellent. And looking at your table, we're looking that we go like from -2, 1, 0, 1. So -2, 1, 0, 1. And that worked with -1, 0, 1, 2. So, looking at number 2, you're going to go to y equal. You're going to clear it out, and you're going to put your new problem in. So x to the 4th plus 2x to the 3rd minus 5. We're going to go to our table, and I'm seeing 1 there, seeing 1 there. Probably start writing on your paper with -3. So we have -3, 22, -2, 5, -3, 22, -2, 5, -1, -6, 0, -5, 1, -2, and 2, 27. So based on that, I should be finding a 0 somewhere here and somewhere here. So your answer here is going to be between -3 and why am I saying between -3 and -2? It should be, yes, between -3, because we went from, that's a -5 right there. We went from positive to negative. Right here is where it is. So between -3 and -2, and then between 1 and 2. Then I would take my calculator, I would go zoom 6, get a basic idea. Hopefully I was right, between -3 and -2, between 1 and 2. Does something weird, you don't have to be perfect with it. It's going to be something like that. Your graphs are not going to be perfect, and that is fine with me. So back to y equal. This time we have negative x to the 4th plus 2x squared minus 1. And we're going to go to our table. I see 1 there. I see an actual 0, an actual 0. I don't see any places where it goes from positive to negative. Okay, and those numbers got really big really fast, so we really don't want to mess with those. So on my table, I would say -2, -9, -1, 0, 0, -1, 1, 0, 2, -9. So I have one at -1, I have one at 1. So I know it's going to cross the graph here and here. I'm going to go zoom 6, and I'm going to see that it goes up, down, up, down. So up, down, down. Once again, your graphs are not going to be perfect. Go to y equal, clear it out, put the next one in. X to the 3rd minus 3x squared plus 4. Go to your table. I've got an actual one there, an actual one there. So there's one. Okay, so let's go with our table. Started at -2, -16, -1, 0, 0, 4, 2, 0. You could plot those points. You're going to tell me there's one at -1 and at 2, and that's because of these two. You can either plot points or you can look at your graph, go zoom 6, get a basic idea of what it looks like, up, down, up. And it's at -1 and at 2, so up, down, up. That graph is not a good one because I have 3 zeros there, right? It's got to go up, it's got to come down to that point and go back up. All right, going to the next page. They're a little bit tricky, but I'm not asking for perfection in these graphs. Okay, so now they want you to find a relative maximum or a relative minimum. A maximum is a high point. A relative maximum is a high point for that area. Minimum's low point. A relative minimum is a minimum for that area. So for example, this one, you don't have an overall maximum or minimum because it goes forever up and down. But for this area, I have a relative maximum. And for this area, I have a relative minimum, okay? And what you do is you look and you see it's getting bigger and then it gets smaller. So this must be a changing, okay? And then we know we're going to have a 0 here. We know we're going to have a 0 here. And then we should have a low point. It was going down and it started going back up. So I have a relative maximum, a relative minimum, and my zeros. So let's look at number 1. What do y equal? Clear it out. We have x to the 3rd minus 3x squared. Go to your table. I have a 0, I have a 0. So let's start with -1 for our table. Okay, on our table we're going to say -1, -4, we're going to say 0, 0, 1, -2, 2, -4, 3, 0. Okay, so I have a 0 here, I have a 0 here. Somewhere in here it's changing direction, right? If you will notice, this was as low as it got, right? So that means that I have a relative minimum at 2, okay, because you use the x. Okay, 2, negative 4 is the relative minimum, okay, but it's at the x value of 2. And then what was the biggest? Did we ever see any larger numbers? Probably right here, because it was small and it went up and then it started going back down. So a relative max at 0. And then if we look at our graph, let's kind of see what our end, let's just see our graph. Okay, we have one relative max, one relative min, that's it. We've listed them. So we are ready to plot our points. We have 0, 0. We have 2, negative 4. We have 3, 0. Okay. What else do we have? Negative 1, negative 4. So we're going to go up, we're going to go down, and then we're going to go up. So go back to y equal, clear it out, and put number 2 in. You have 2x to the third plus x squared minus 3x. So let's look at the table. And I see an actual 0 at 0 and at 1. It is getting, so there's probably, it's going higher, higher, higher. If I look up here, numbers are getting smaller and smaller. Let's just take a glance at our graph. And it is going to have one relative min and one relative min, one relative max and one relative min. So let's look and see kind of what we can do here. Go back to our table. And I would say let's start with negative 2. So looking at our table, we have negative 2, negative 6, negative 1, 2, 0, 0, 1, 0, 2, 14. So as we're looking, it starts out at negative 2, negative 6, which is somewhere down here. It's going to get up here at negative 1, 0. We're going to have 0, 0. We're going to have 1, 0. And we have 2 with way up there. So we know it's going to do this. We know it's going to do this. We're going to look back at our graph. It's going to go up, down, up. So it's going to go up, down, up. We need to figure out about where the relative max is. Looks like it's about here, probably at, oh, that's a 2, not a 0, right there. So I would say relative max at negative 2. No, it's positive 2 at negative 1. So you have a relative max at negative 1 because that's a high spot. And then you have a relative min at probably 1. It's not really going to be 1. It's not going to be 0. It's got to be between 0 and 1. So could we say 0.5? Or you might want to say between 0 and 1. That'd probably be your best answer on that. So relative max at negative 1 and relative min between 0 and negative 1. All right, let's try number 3. Go to y equal, clear it out, and we're going to say 2x to the third minus 3x plus 2. Just take a glance at our graph. I do have a relative min, I do have a relative max. So let's go to our table. And let's put our numbers from the table over here on our paper. So we have negative 2, negative 8, 1, 3, 0, 2, 1, 1, 2, 12. So we're getting bigger and then we're getting smaller. So here is a relative max. We're getting smaller and then we get bigger. So here should be a relative